Hello viewers, welcome back again to my common algorithm series. In this particular video, we are going to look at how to reverse a given array or a list. It's important I mention that we can use the same approach to reverse an array and a list. The reason is because both of them most times share the same algorithms, especially with respect to the fact that both of them have the common attribute of making use of indices to access their individual elements. So without any further ado on this, the example we are going to use to explain this particular concept is a list that contains the values A, B, C, and D, which are located in the indices 0, 1, 2, and 3, respectively. We are going to take a look at this concept or approach using 3 different steps. And these 3 steps have to be iterated. That means repeated. The first step is that we have to first of all create a temp variable. Now this temp variable is going to be holding values temporarily. It's not going to hold it persistently, but just for a period of time, in order for us to be able to make very good use of the concept. So the first thing is that we want to grab the last element, which is in this case D, and store it in the temp variable. And the second step, as you can see, is that we take the first element, which is A in this case, and now bring it to the position 3. Remember, at this point we no longer have D contained in here because D has been stored temporarily in temp. Now whatever we had in D, which is now stored in the temp, we now have to be stored back to A. Remember at this point that A has been taken to D, so it's more like saying that A is now empty. Let's look at iterations to actually consider this in a better perspective. Looking at this value, the first iteration reads: we take the last element, which is D, and store in the temp variable. The second step is that we remove the first variable value and store in the last position, which is in this case. Now what happens to this? We grab the D and now store it in the first position. So this is exactly what we're doing at this point. Second iteration, because we are not done, take note of this. We just considered the last extremes, the 2 extremes on the left and on the right. That means the first value on the left and the last value on the right. Now where we want to concentrate on at this point in time is going to be B and C. Alright, so how do we take care of this? It is still the same step of taking the last value, which is C, which is stored in the position 2, and store it in the temp variable. And the next thing is that we want to take the first element, which is in the position 1, and store it in the same second position, which is 2. And of course, remember, we've removed what was in the 2 and placed it in the temp. Now we take what was in the 2, which is now stored in the temp, and place it back in the first position, which is C now at this point. So this actually concludes our algorithm. But how do we implement this using a pseudocode? Let's look at this. We are also making use of the same list, except that in this case we have been able to give the list an identifier, that is a name. Alright, now first thing we have to do is that, remember, we are moving forward and at the same time we are moving backward. Alright, so the index that moves forward is 0. Okay, forward index has been initialized to 0, meaning that we want to start from this point and also be getting to this point closer. And the one that should take from 3 towards the left hand side is going to be backward index. And this backward index simply means the length of this list minus 1. Why is it like that? We have 1, 2, 3, 4. And how do we get 3? Because 4 is not the last index. We have to subtract 1 from it. Exactly what we are doing here. So what we want to consider is that while the forward index is less than backward index, they must not be the same. While forward index is less than backward index. Remember that we want a situation whereby if we get to this point, right, there should be at this point a swap between this and this. So when we get to this point, we stop. What this means is that 1, which is the index here, is less than 2, which is the index for the last value. So that is what we have just established here. Now, while the forward index, which is supposed to start from 0, is less than backward index, which is supposed to start from 3, we perform the operations we described earlier. Store the last element, which is D in this case, alright, to the temporary variable, temp, and take the first element, which is A, and now store it in this position. Alright, like we described. So my list of backward index will now hold the value of the first element in the list. Now the first element will now hold the last element, which is now stored in the temp variable. Remember, our forward index is increasing by 1 and our backward index is decreasing by 1. So end while, and let's look at our trace table. We have forward index 0 and backward index 4. So at this point with our algorithm, forward index 0 means that we have the value A, and backward index 4, right, sorry, is supposed to be 3, not 4. So this is supposed to be backward index 3. Okay, we have D at this particular index. So what this means is that our A is replaced with D and our D is replaced with A. And we move on to increment our forward index by 1. And of course, 3 is decremented by 1 to give us 2 in this case. It's supposed to be 2 at this point. So we are considering this and this. So there is a swap again. We have C and B swapped accordingly. So because we have 2 here and we have 1 here, now this increments by 1 and it becomes what? This increments by 1, it becomes 2. And this decrements by becomes 1. So it has actually violated the rule because forward index is supposed to be less than the backward index, as this case suggests. So this is actually how to look at your algorithm by dry running using traceTable. I hope this makes your day. Kindly subscribe for more viewing because you get to get more contents from here. Thank you for watching.